Hi guys, Duncan here from One Sightsolutions. This is a recording of a presentation I gave at the Smart Building Show at London's Excel in October 2024. I hope you enjoy. Okay, so thanks for your interest in this recording. To start with, we're going to briefly cover what Smart Enablement means, and then we're going to go into the challenges involved in putting together a smart enabled building and some of the best practices that you can employ along the way. These are going to be lessons from the trenches, and we'll cover choosing the right underlying communications protocols, security practices, naming conventions, and we're going to wrap it all up with possibly the most important topic for Smart Enablement, which will be around validation, which is making sure that we've done it all right. So a quick introduction. Myself, I'm Duncan Greene. I'm the Project Infrastructure Lead here at One Sightsolutions. My background is originally in computer science, and I've spent the last 15 years or so working in the industry for companies that deploy large-scale IP networks and smart building systems across the UK. My role at One Sightsolutions is to help bridge the gap between IT and OT and the R&D and Operations side of the business. Part of that latter role is looking for gaps and potential improvements that can be made in the project delivery process, and that's helped to inspire some of the best practices that we're going to talk about today. So, smart buildings in 2025, where are we at? Start with, we've got an ever-growing list of systems going into modern buildings that people want to get data out of and have control over. Some of those are shown on screen, so lighting, HVAC, security, and nowadays other systems such as lifts, room booking systems, catering, smart lockers, people counting systems, wayfinding, digital signage, etc. Now, as disparate as these systems are, there are common themes amongst all of them. Nowadays they're often ultimately connected to IP networks. Consequently, they'll often have some element of security concerns as a result of that. The devices and points in these systems will all need to be given names to identify them, and they'll all undoubtedly require some level of integration. Smart enablement is all around getting this integration right and making sure that the data from these systems is available to any other potentially not yet existing systems in an organised and standardised way. So, as touched on, there are loads of different systems that we can integrate with and smart enable. And thankfully, more often than not nowadays, these systems will be using one of the widely established industry standard protocols that are on offer. Some of the standards are shown here on screen, and some of them, such as BACnet, KNX and DALI, all have rigorous certification programs. Certification of devices offers a guarantee to the end user that the devices implement the protocols correctly and will function as expected. The three standards that I mentioned list any certified devices on their websites. Now, with an eye on smart enablement in particular and making sure that we can get the data from these systems that we need, it's not always sufficient just to look for the certified stamp on a device and move on. As some viewers may appreciate already, the devil is in the detail with these things. Some features in these standards may be mandatory, for example the actual mechanics of their addressing and communication processes. Some features may be optional, for example what data they actually expose. So as a bit of an example, let's say we've got a requirement to get some specific diagnostic data from some emergency light fittings in a public building. Now, just for folks that don't know, emergency lights are the ones that are designed to come on in a mains failure, powered by batteries, to light up escape routes. These require monthly testing as part of building safety regulations, and if you buy an emergency light fitting with a DALI inverter inside it, for example, this testing and feedback reporting can be automated. Now, I won't go into the nitty-gritty of DALI too much, but a DALI application controller is the device at the centre of a DALI system that orchestrates the commands out to the DALI light fittings. It tells them to do their monthly test, reads back the battery charge, etc. So on screen now is a list of all the certified DALI products, which you can see on the DALI Alliance website if you wish. There's over 5,000 of them currently. If we take a look at the list of certified application controllers though, we can see that there are around 678 of them at this present time. Now, we need an application controller for our example that works with DALI emergency light fittings and that can offer the enhanced diagnostics data that we're after for our smart enablement job. So we can filter that on the left hand side there for specific application controllers that support those specific features. Now that reduces our list of available products from 678 down to 32. Now, the point I'm making here with an eye on best practices is to do your due diligence. Just because the device has the stamp of the standard on it, always check that it's going to offer the exact functionality that you need. And if you're not comfortable checking this sort of thing yourselves, make sure you engage and work with a partner that can. Now, when we talk about smart enablement, the term MQTT often follows closely behind. Just as more and more organisations are looking to leverage cloud tools such as Power BI for analysis of their business data, there are a few organisations out there beginning to leverage these same cloud tools for analysing data from their buildings. The problem? Tools like Power BI and the platforms that they run on, such as Azure, AWS, etc., they don't natively talk BACnet or KNX or, funnily enough, Modbus, but they do talk MQTT. Now, for anyone not familiar with MQTT, on the face of it, it's a super lightweight communication protocol. Essentially, devices publish values to something known as a broker in the middle, and then the broker allows other devices to subscribe to it to receive those values. Very, very broadly speaking, you can liken using MQTT to transfer temperature values, as shown on screen, to using HTTP to transfer web pages. Think of MQTT and HTTP as the envelopes, if you will, that you write the address on, where you want to send the data to or what website you want to go to. And think of the letters that you put inside those envelopes as the messages, the temperature values or the web pages, etc. Now again, this is where the devil is in the detail. Some of you may be aware that web pages are written in HTML, which is very nicely structured and standardises the syntax for things like web page titles, headings, how to embed images and hyperlinks. There are defined ways or tags to implement those things so that all web browsers, whichever one you use, can understand them and present the data, the HTML, the same to you as it does to me. Now, we need to make sure we do a similar thing when sending data via MQTT. One of the most popular formats that you can use to send data is called JSON, which stands for JavaScript Object Notation. Now, this is all well and good. JSON is structured and it's human readable, but without a defined convention or schema, you are free to make up your own rules. Now, I've got an example on screen here of somewhat unruly JSON. If you kind of read down this, you can see that in some instances I've used uppercase characters for some of the letters in here, complete lowercase in others, underscores down at the bottom, symbols. We've used question mark on the end of this one. The values maybe not particularly suitable. Battery knackered, very, not very. It's not particularly well thought out, and equally not very consistent for a computer to read. So one of the things that we want to seek to do here is to apply some mechanism of standardizing the actual content of the JSON payloads as well. Now, one such example of this is to use something called UDMI, Universal Device Management Interface. So this particular standard or program aims to apply a schema, a particular schema, to define how the key value pairs, which you can see on screen, so the keys are the bits that are written in the lighter blue, the values are the bits after the colon, how these should be formatted and structured. Now, we're going to dig into this a little bit later on, so we'll come back to this one. Now, I'm going to jump on to security. Now, as we're all probably aware, operational technology, OT, is now under threat more than ever. A big part of this could be attributed to smart building protocols utilising IP for their network layer. As soon as something becomes IP connected, if the conditions are right, the attack surface is greatly increased. And this places a big onus on the security of the IP network. Now, IP networks are traditionally an area left to IT folks, and the good news is they've been dealing with security for decades, and you can help them out, us when we're doing these smart enabled projects. Converged IP networks are nothing new. A little bit of history here for anyone that isn't aware. The idea of a converged network is running all of your IP services on top of one shared set of network infrastructure. Think servers, PCs, desk phones, CCTV cameras like we've got on screen. 20, 30 years ago, these may have all sat on physically separate IP networks with their own network hardware. But nowadays, they'll all aim to share the same infrastructure typically using concepts such as VLANs or virtual LANs to facilitate this. And there's no reason why all of our IP connected systems that we looked at the very start cannot sit on the same converged network. So where do we come in as a system integrator with an eye on best practices? To advise on the segregation and what needs to talk to what. The IT folks might well assume that lighting devices don't need to talk to HVAC devices. But what if we know that the occupancy signals from the lighting presence detectors need to be shared directly with the fan coil units on the HVAC system? It would be negligent of us to ask for the two VLANs entirely to be able to talk to each other. Instead, if we can, we should be advising specifically what devices may need to talk to what other devices specifically, and using what protocols. And let the IT guys handle the relevant routing and firewall and the rest of it. And let the IT guys facilitate the remote access too. Gone are the days where we should be leaving 3G, 4G routers in riser cupboards on sites. Now, just because the network side of things may be handled by someone else, that doesn't absolve us or the smart building industry of our duty to secure these smart building systems. Now, thankfully, the associations behind a lot of the standards already mentioned have been taking action. The KNX Association was one of the first to do this, standardising KNX IP secure and KNX data secure to encrypt KNX over both IP and serial-based communications. Other standards bodies are taking action too. ASHRAE followed suit with BACnet SC to secure BACnet over IP-based communications, and others will likely follow suit. If we use an MQTT, as we looked at earlier, consider running MQTT over TLS with things like certificate-based user authentication. Now, a very quick note here on certificates as well. Some viewers may be familiar with the certificate is not valid warning that you can sometimes see in a web browser, maybe when you browse to a BMS controller or something. Encryption relies on the use of certificates at its core, and someone should take responsibility for properly managing and deploying valid certificates to devices on a network. This overall concept is known as deploying or managing a public key infrastructure, or PKI. Make sure someone responsible and qualified is taking responsibility for deploying this. Now, government legislation is set to hopefully make smart buildings more secure too. In April 2024, the PSTI, or Product Security and Telecommunications Infrastructure Act, came into force. Now, this law requires that manufacturers and distributors of UK consumer connectable products, or smart products, need to comply with some minimum security requirements. Now, these are things such as mandating no more universal default passwords, no more admin. Provide a clear way to report to the manufacturer any security vulnerabilities if you find any, and transparency from the manufacturer as to how long they'll provide security updates for that product. Now, whilst these regulations are targeted at consumer connectable products currently, we may well find that they come to play a bigger part in the commercial space too over the next few years. The takeaway here is to be cognizant of security. Don't ignore it. Okay, so moving on to naming. I'm going to divide this up into two main parts: equipment naming or device naming, and a point naming as well. Now, focusing on equipment naming for a start, naming of things is incredibly subjective. Some folks will want to be able to establish at a glance from a name things like what it is and where it is. And on the face of it, this sounds simple, but it can be very hard to draw the lines. Now, let's take a light fitting with an arbitrary name like we've got on the screen there. Some folks might want to know at a glance from its name in a report or an alarm console when they see it, whether it's a normal light fitting or an emergency light fitting. And so we might add a prefix, EM, for emergency on the front of it. Whether it's LED or fluorescent, maybe we could append on the end .FL for fluorescent. Whether it's located on the basement or on the roof, in a customer facing front of house area or a back of house area that's maybe not so important. Where do we draw the line? If this was a fluorescent lamp and I replaced it with LED, does that mean I've got to rename all of my light fittings? You can see the problem with stuffing this information or metadata into a device name. Now, experience has taught me over the years that you shouldn't stuff mutable or changeable information into equipment names, and abstracting detail away from names, out of names, isn't a bad thing. All those properties we just spoke about, LED or fluorescent, basement or roof, it's all metadata. The location can be inferred exactly from the BIM model or the lighting drawings. The lamp type can be established from the luminaire schedule in the O&M manuals. Those are the sources of truth for that information. Putting it anywhere else just duplicates it and gives you one more information source to update when something changes down the line. Now, I'm not suggesting that we should just give everything a number 1 to 1,000. Of course, some context in a name in a list might be useful. One source for inspiration that you could consider is the Building Device Naming Standards Initiative, or BDNS. The BDNS project provides a list of abbreviations for building devices. You've seen some of those in the top left-hand corner, along with some guideline naming principles towards the bottom, and some example references are shown on the right-hand side. So LT-15 AHU-3. Now, a quick note here, just to note, down at the bottom you can see where in the formatting it refers to this building unique incremental number. This is the index, if you like, that is increasing on the right hand side of the hyphen in the references. Now you can see there it refers to non-zero padded. Now, zero padding is illustrated here on screen. It's when zeros are added to the start of a number. And it causes computers problems because LT003 to a computer could be interpreted as LT3, but to you and I, LT003 and LT-3 may well be different things. So the BDNS advocates for no zero padding to avoid this issue. We'll revisit this a little bit later on when we get to our validation section. Now, just additionally as well, BDNS does say at your own discretion that you can seek to encode some spatial or zonal information as long as it's numeric in the index part of the reference. For example, you may choose to nominate the first few characters to represent the floor or zone number. Proceed with caution if you're going to do this. Got an example here of LT-1303. Now, this causes potential problems here because is that referring to the third light fitting on the 13th floor? Is it referring to the 303rd light fitting on the first floor? Is it referring to the third light fitting on the 130th floor? If you are going to try and encode information such as this in equipment names, be wary and be prescript on the number of characters if you are going to do so. Stipulate that the first two characters will illustrate the floor number, for example, and just hope that you don't do any projects over 100 floors, if that's the case. Now, we'll revisit naming towards the end of the presentation for devices. Now for point naming. This should be a bit of a simpler one. Just as much as humans like to read equipment names, humans and computers like to read point names too. Trying to standardise on point names can be a lot trickier, but for anyone out there that's worked on systems with hundreds and thousands of points, you'll no doubt appreciate that having points named consistently is key. One such source of inspiration you can use for point naming is Google's Digital Building Ontology project, and in particular their concept of fields and subfields. There are tutorials on the DBO repository that can get you started on this, but essentially they prescribe a particular order of terms that you can use to build up your point names. As an example, it prescribes using words like status instead of state, command instead of CMD, etc. And by adopting a naming convention such as this, not only does it make life easier for your engineers, so they know how to name everything, it also makes it easier for other third parties and other third party systems to interpret those point names too. The takeaway on naming is to decide on your convention, make sure it scales accordingly, get the word out to trades and other people that are going to be naming things as soon as possible so that everyone can start using the same names to refer to the same things, and make sure you stick to it. Testing. Now, this is going to be a quick one. It felt remiss not to mention testing in a talk on best practices. I'm not going to labour the point. Test your systems, test your security, and test your naming conventions work. Do the proof of concepts, do the factory acceptance tests, do the site acceptance tests. Because once you think you've got it all tested and working, we can move on to the next section, marking the homework. Okay, so validation, saving the best bit till last. Now this is possibly the most underappreciated part of Smart Enablement by far, and at the same time the most important. Now validation, specifically from a Smart Enablement point of view, is all about making sure that we've got the correct point values with the correct point names, coming from the correct devices with the correct device names, and a whole host of other things. Now validation is achieved by asking questions of the data. Now let's take that UDMI representation of some points from that emergency light fitting that we were looking at earlier. We can see that on screen here. Now some questions that we could ask of this data that's shown there. Are all the points that we're expecting included in there? We've got battery charge sensor, brightness percentage command, brightness percentage sensor. Are there any points that we aren't expecting in there? Are the points named correctly? Maybe in accordance with DBO that we were looking at earlier. Are the point types as expected? Is there a Boolean value where there should be a Boolean? Is there a numeric value where there should be a numeric? Are the point values sensible? Do they match the values in the originating system? Is the light fitting indeed dimmed to 66.3%? Are any writable points indeed writable? Is the JSON even valid? Are the curly braces and the brackets and the commas and everything in the right places? Are there quotation marks around the strings where there should be? Is the topic structure right? If we're talking about MQTT, this bit at the top where we've got GB lon XYZ /lighting /LT101, is that correct? That's a dozen questions that we could ask just of this point data on screen alone. Now, unfortunately, we're not going to have time to cover how to check all of these things, but I will run through how we might go checking the couple of the last ones that I mentioned, which is validating the equipment names. Now, I'm going to introduce you to something called regular expressions for anyone who's not aware. You will have seen regular expressions in action plenty of times, potentially without realising it. Regular expressions are the thing that tell you off when you enter an invalid email address on a form. They are the things that check that it contains an @ sign, a number of full stops, letters, numbers, etc. So, a bit of an example here on screen. This is a regular expression that can validate a mobile phone number. So as we all know, mobile phone numbers, at least in the UK, all start 07 and then are followed by 9 numbers following that, between 0 and 9. And we can see we've got some test strings in the bottom section of that screenshot there. Those are the strings that I'm running against my regular expression, and the regular expression is shown at the top. Now I'll just walk you through this regular expression. So to start with, I'm stipulating that it must have a 0 and a 7. And then within the brackets there, we've then got a bit of a couple of things in here. In between the square brackets is a range between 0 and 9. This is essentially saying that I'll accept any number between 0 and 9 in between my square brackets. And in between the curly brackets, I'm saying that I wish to see 9 instances of that previous token. And so we can see that when we run these test strings against there, the ones that are coloured in are valid. They meet the regular expression, they match it. But there are a couple that don't. If we have a look at this, the fourth one in the list, we can see that it looks okay on the face of it, but actually it's missing that 11th digit. And that's why this doesn't match. This hasn't matched the regular expression here. The very, very bottom one begins 06. It's got 11 digits, but it begins 06. That doesn't meet the regular expression. So this is where the power of regular expressions can come in. Now, as we touched on before, let's consider using BDNS for our equipment names. Now, BDNS kindly provide a regular expressions as a starter for 10 in their guidelines. And I can show that on screen here. So what we've got is the first part, we're accepting any capital letters between A and Z. In between our curly braces, we're saying that we want to see between 2 and 6 of them, so we can't have infinitely long abbreviations, so between 2 and 6 characters there. A hyphen then, and then we're looking for a number between 1 and 9, and then a number or an infinite number of digits between 0 and 9 following that. Remember that 0 padding thing that we spoke about earlier? This is where this can be mitigated. And by stipulating that there must be a number between 1 and 9 to start with, that's how we can exclude zero padded numbers from our names if we're running any references against this regular expression here. The asterisk at the end that's coloured in blue is essentially the equivalent of this term here, but it's indicating that we can have infinite number of tokens repeated there. Now, on the face of it, all looks okay, but there is one problem with this regular expression. For anyone who's sort of familiar with BDNS, or at least device references in the smart building world, that one at the very, very bottom, QQQ, might be raising a few eyebrows. And the problem is, QQQ is not a valid abbreviation in the eyes of BDNS. So this is a problem. Now, we can fix this by extending this regular expression, as I've got here. Now, what I've done is I've swapped out that dynamic bit to start with to include essentially every single abbreviation that BDNS allows for, separated by that green pipe symbol, which is essentially an OR operation. So we're saying, TK or TL or TM, CLK, or and the rest of it. And by doing that, we can precisely stipulate which abbreviations we're gonna actually accept. And we can see now that QQQ is no longer matching, which is great. Okay, so let's take it one step further and make life a little bit harder for ourselves. Let's throw in the added challenge of encoding a zone number and a floor number in the name before the index. So what we're going to have our abbreviation to start with, then a hyphen, then a zone number of 1 digit in length, floor number to use 2 digits, then an incremental number which will be 3 digits long. Now we know that last string there, or that series of digits, is always going to be 6 characters long. So what we could do is we can refine our regular expression to simplify it to just accept at the end any digits between 0 and 9 and make sure that there are 6 of them. Now we can see there that we're now excluding AHU-1 and FCU-1607 because there's not enough characters in the last part of that reference. Now this looks okay on the face of it, but let's just check. By reading these references here, the second one down in the list, we're saying that there's an 87th floor in our building. Now, unless we're building higher than the shard, it's unlikely. So let's just tighten this up a bit. Let's say that our building has 12 floors, and equally, let's also tighten up the zone numbering. We may not have a zone 9. So let's to simplify this, let's just say our building has 6 zones as well. Now what we can do is we can extend this regular expression further. Now what we're looking to do is in the first brackets here in green, we're looking for a digit between 1 and 6. That's reflective of our zones 1 to 6. We're then going to accept a floor number between 01 and 12. Now I've specifically spaced these all out here, instead of just saying 1 to 12, to make sure that we capture that leading 0, the 0, 1, 0, 2, 0, 3. These zeros here are okay. The concept of zero padding does not apply in this naming convention that we've decided on with these 6 digits, fixed character length. And then lastly, we've got our 0 to 9, where we're just looking for 3 matches of that previous token there. Now you can see now, none of those names are valid all along. So this is the power of regular expressions here. It just shows what you can do to validate these names. Now if we add in a couple of extra light fitting references just to test the theory, you can see there where the individual fields have been matched against those particular rules. Now the point with all this is you can see just how much effort and attention to detail is involved in just validating one aspect of that single JSON payload for just one emergency light. Now, thankfully, we have developed a bit of a tool that takes care of vast swathes of this sort of checks. It's called Smart Build Connect. There is a demo of it available on our website shortly, and it takes care of a wide range of validation tasks. So checking for duplicate names, checking for expected and unexpected MQTT topics, the list goes on. And it's worth noting here, as we know, smart building systems are ever evolving. We've all lost count of the amount of adds, moves and changes that happen over the life cycle of a building. So validation should be a continuous process that you run throughout, ensuring that everything is always as expected. So, in summary then, summary of our best practices. Systems. We need to choose the right protocols and systems to start with. Make sure that the standards you use are widely established, that they're future-proofed, and make sure that the devices that you use have the relevant certifications. Make sure that you can get the data that you need out of these systems. Make sure that you can extract device lists and points lists so that you can validate them afterwards. Be mindful of security. Work with the IT teams, allocate someone to look after that public key infrastructure, and don't leave the password as password. Name your stuff. Remember that namespaces also will protect you from running out of names. There's no reason why you can't have AHU-1 in one building and AHU-1 in another building. Have a hierarchy to these things. Decide on a naming convention that works for you. Be prepared to back it and get the word out to trades and other stakeholders as to use it as soon as possible. Do the testing. Can't say much more than that. And do your validation. Cannot overstate the importance of this. This is the last piece of the puzzle for Smart Enablement, making sure that everything is present and correct. And just a quick note here as well. Just want to mention the Digital Building Council for anyone unaware. This is a not-for-profit collection of folks from the smart building industry, including some people from One Sightsolutions, who are all working together towards a more collaborative approach for smart buildings, sharing best practices such as these, and hopefully making all our lives easier in years to come. Do go and visit their website to find out a bit more, and do by all means reach out to myself and the team at One Sightsolutions. We'd be more than happy to go into more techie detail on some of the things that we've covered during this chat. And if you do have any questions, by all means drop them in the comment section below. Reach out to us on socials or through our website, and hopefully catch you next time. Cheers, guys.